Okay, good afternoon. This video today we're talking about scientific notation. Hopefully last year you've got some scientific notation down, and this is just a review to remind you about these facts. Okay, so let's get some definitions down. The first definition you see is standard form, the way we normally see a number written. Example, you've got 83, 000, 000, there's those numbers there, that's 83 million, and that's how you see that. The next definition is scientific notation, a shorter way to write very large or very small numbers. Example, you've got 8.3 times 10 to the 7th power, and in that 8.3, that first factor has to be a number that's greater than 1 or less than 10, and that second factor uses your power of 10. So you've got a number here, a multiplication sign, a power of 10, and an exponent. So now that we have our definitions down, let's look at some examples. Okay, the first couple of examples, we're going to convert to scientific notation. Well, according to our rules, we know it has to be a number that's greater than 1 and less than 10. So I like to come over here and I'll go ahead and put my line. And then I would go ahead and put a box around the rest of those numbers. So I know I'm going to have 7.5. I need a multiplication sign. I know I need a power of 10. And I can count what's inside my box to give me what my exponent is. So I've got 1, 2, 3, 4, 5, 6, 7. So I've got 7 numbers inside my box to give me my scientific notation. So I've got my standard form here, and I just put it in scientific notation following those rules. Now this is a pretty large number, 75 million. This number is a very small number, so it's going to be a little different. But I still have to follow those rules. So I'm going to come over here, and I'm going to follow that first rule, a number greater than 1, less than 10, and I'm going to go ahead and build my box to my decimal point. So I know my first number is going to be 5.08. I have to have a multiplication sign, have to have a power of 10, and now I can count what's in my box to give me my exponent. 1, 2, 3, 4, 5, 6, 7. So there's 7 numbers in my box to give me my exponent. So here we have our standard form of a very small number. So what's going to be different about my exponents? This is a very large number. This is a very small number. I need to have a negative exponent. Because I know to put that back, I've got to go to the left. To get that number back where it needs to go, I went to the left, and to get it back, I have to go to the right. So when you have a decimal and a bunch of zeros, you know you have a very small number, and you need to have a negative exponent. Now let's do a couple more examples. Okay, so here we have another very large number, 500,600,000. Okay, so I'm going to draw my box right after that first rule that says a number between 1, greater than 1, less than 10. I'm going to draw my box. I go ahead and I say 5.6 times my power of 10. I count inside my box 1, 2, 3, 4, 5, 6. There's my exponent. Now, is that going to be a positive exponent or a negative exponent? It's a large number, so I have to have a positive exponent. I look down here, I went, oh, that's a really, really tiny number. So I'm going to come over here, follow that rule, number greater than 1, less than 10, draw my box to the decimal point, follow that first rule, 2.1, multiplication sign, power of 10. Is my exponent going to be negative or positive? Well, it's very small, so it's going to be a negative exponent. I'm going to count what's in the box, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a negative 9. So that takes this number in standard form, turns it into scientific notation. Let's go the other direction. Okay, here are our next examples. These numbers are in scientific notation, and we're going to put them in standard form. So first we have 3.79 times 10 to the 7th power. So I'm going to go ahead and I'm going to say 3, and then I've got to count here. and I've got the 7, 9, I'm going to count from my decimal, and I'm going to go 1, 2, 3, 4, 5, 6, 7. And my decimal goes away. And you can follow the bouncing ball here. And now go in and put your commas. You got 37,900,000. A very large number. Okay? This one got a negative exponent. Is that going to be a big number or a small number? So I'm going to start with this 1. Pretend like, remember, that's a whole number. A decimal goes there to the right. So I'm going to do, I need to give me some more space because I'm going to be going backwards with that 1. So I've got to go back 9 places. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, decimal point, put a 0 to keep my place. Did I do that right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoops, got too many zeros. Take that out. Always check. Make sure I did that right. See if I made a mistake. Okay? Let's look at a couple more examples. Why don't you give these a try yourself? The first one is 2.8 times 10 to the 4th power. That's in scientific notation. Go ahead and put it in standard form, and then you can check back and see how you did. And the next one, 1.302 times 10 to the negative 5th. Go ahead and put that in standard notation, and we'll check back and see what the answers are. Okay, so here are the answers. Hopefully you got these right. 2.8 times 10 to the 4th power is actually 28,000. 1.302 times 10 to the negative 5th power, you've got 0.0000132. It's a very small number. Okay, that takes us to just about the end of our video. So on your summary at the bottom of the page, you want to write down how do you determine whether to use positive or negative exponents when using scientific notation. And that should be it. Be ready tomorrow to ask some questions, and we'll answer those and talk about scientific notation a bit.